Welcome back to Smitty's Learning Room. Today we continue with the HSC Core 2, Factors Affecting Performance, and having a look at the energy system. So the previous video gave us a bit of an overview of what the energy systems were, and today we're going to have a very close look at the three different systems. So we start by having a look at where this content comes from in the syllabus, and it still comes under that focus question, how does training affect performance? Still having a look at these energy systems, learning about them, but today we start having a look at the students' learn to side and having a look at the source of fuel, efficiency of ATP production, duration that the system can operate, cause of fatigue, byproducts, and the process and rate of recovery for each system. Before you get started today, I suggest you create a table like this in your workbook to help you summarise each system in relation to the syllabus dot points. It's really handy to be able to look at each one and compare them when you're making your study notes and when you're studying for your exams and assessments. As you play the video, obviously you'll go back to this table and fill out the table as the notes come up. We'll start by having a look at the anaerobic energy systems. There are two anaerobic systems, and the first one we look at is the lactic acid system, or more commonly known as the ATP-PC system. So given that this is an anaerobic system, we know that it produces energy without the presence of oxygen. And obviously there's advantages to this as it allows a faster supply of energy, but also has the disadvantage of being limited energy supply. So let's start having a look at the structure of the ATP-PC system. So in the body we have, or in the muscles, we have this ATP, which is A, which is an adenosine, and then we have T being triphosphate. So we've got three phosphate molecules there and an adenosine molecule. How we get energy is that one of these phosphate molecules breaks away from the ATP and we end up with energy to allow us to do muscle contractions. This obviously then becomes adenosine diphosphate because we've only got two phosphate molecules left. For us to be able to produce more energy again with an ATP molecule, the body must seek energy and creatine from food to recreate the ATP from the ADP, and this is called the resynthesized stage. So we go from ATP, we lose a phosphate molecule to create energy, and then we become ADP. We then gain another phosphate molecule and a creatine molecule from the food to become ATP again to create more energy. So if we have a look at the source of fuel for the lactic acid system, or the ATP-PC system, it's creatine phosphate. The efficiency of the ATP production is very quick production because it's already there sitting in the muscles ready to go, but obviously because of that it only lasts for a very limited time. When we look at the duration intensity of it, it's about 10 to 12 seconds of high intensity, so like 95 to 100% maximum effort that the body can fuel itself from this type of energy. And obviously fatigue is caused by the fact that there's limited stores of ATP in the body or in the muscles. Now there are no byproducts of ATP, so once the ATP molecules have been used up, there's nothing that's going to be left behind that's a chemical in the body, say like the lactic acid system. Now the recovery process is highly dependent on the intensity of the activity, but the activity intensity decreases or ceases once that activity stops. We can start to reproduce or resynthesize that ATP-PC production. One thing you'll notice that with recovery rate, the breathing is increased so that the PC can be replenished in the presence of oxygen, so a lot quicker. And when we look at the recovery rate, it's about 50% recovered in approximately 30 seconds, but fully recovered within sort of 2 minutes. So this is where we can have a short break in between short bouts. So for example, if you're just doing a couple of weight lifts in the gym, you could then have 2 minutes break and then go back to another set of weights within the gym. Examples that use this energy system for sport are obviously sports of high power. So for example, athletic events such as javelin, discus, shot put, 100 metre sprinting. When we look at team games, sports like baseball, or even a quick change of direction in rugby league, or hitting a ball in hockey. And coming into the gym, having a look at something like bench presses of 1 to 6 reps maximum. So the main thing to remember about the ATP PC system is it's that short, sharp burst, quick supply of really high intensity energy. The second anaerobic energy system is the lactic acid system, and obviously being anaerobic means that there is no oxygen present for this system, and obviously again provides quite a fast supply of energy but is limited due to the lack of oxygen. The lactic acid system to supply energy is limited because of its byproduct of lactic acid. Doing activities which requires a lactic acid system means that athletes who are training this system need to have a very long recovery break to allow for the lactic acid to be cleared or removed from the body, to allow the acidity in the blood to be decreased or reduced so that the athlete can begin to perform again. Sometimes this might take a few minutes to half an hour, sometimes it can take up to 2 hours. So if we have a look at how energy is actually produced for the lactic acid system, we have glycogen that's in the muscles or in the liver, and it then comes into the muscles to produce energy, or ATP. Now what happens is when glycogen is used for energy, we have this byproduct of what we call lactic acid, which is like a hydrogen chemical in the muscles. And this is when we sort of get the terminology of hitting the wall. So, you might go for a run quite quickly, and then all of a sudden you start to feel sick, or your legs get a little bit shaky. And that's what's happening, is that the glycogen is creating energy in the muscles. And as a result of that energy happening, you're getting acid, essentially hydrogen, in your muscles, which is causing your muscles to fatigue or hit the wall, so to speak. So if we have a look at the source of fuel for this, it's carbohydrates. So we talked about the fact that it uses glycogen, which is stored in the muscle and the liver, and it can also use glucose in the blood. We know that it's a quick ATP production because it doesn't require oxygen, but still fatigues quite quickly as lactic acid levels rise and sort of acidosis starts happening in the muscles. Now, this lasts a little bit longer than the ATP-PC system, so we're looking at 30 seconds to 3 minutes depending on the level of intensity. So activity sort of that's 70 to 95% of maximum effort. The main cause of fatigue for the lactic acid system is the accumulation of lactic acid, which is due to an increase of hydrogen ions in the muscles. And obviously the byproduct of this system is lactic acid. When we start having a look at recovery processes, once you decrease the intensity of activity, you're going to start recovering from this process. And again, like the ATP-PC system, an increased breathing rate will help O2 or oxygen get back into the blood, which helps break down the lactic acid. As we said before, it can take anywhere from 30 minutes to 2 hours to recover from this energy system which is being used. The perfect example for this, for sports using this system, is middle distance runners in athletics, so like 400 and 800 metre runners, or in swimming, looking at, sort of 1 to 200 metre swimmers will use this energy system. Finally, we move on to the aerobic energy system. Now, going back in from the prelim course, we know that the aerobic energy system uses oxygen to provide the body with energy. So we know that we have the glycogen from the liver and the adipose tissue and proteins as well, and triglycerides in the muscles are combined with oxygen to create energy. And then therefore we have ATP in the muscles ready to go again. So we know that this is an aerobic energy system, but it also means that because it is aerobic, it provides the body with energy a lot more slowly than what the anaerobic activities do. So if we have a look at the source of fuel for the aerobic energy system, we've got carbohydrates, which are stored in the muscle and liver as glycogen. and then we've got fats, and in very rare cases, proteins, which are then combined with oxygen to provide us energy in the muscle cell. How efficient is the ATP production when used by this energy system? It's a slower ATP production, but it's an endless supply. So once the body starts pumping oxygen around the blood system, basically means that we can have an endless supply of energy. Obviously, that's based on the capacity of our muscular endurance and a lot of other aspects, but once the oxygen starts being delivered through the blood to the muscles, we've got endless supplies of energy. If we look at the duration and intensity, again, at low to moderate levels of intensity, less than 70% of our maximum effort, we have an endless supply of energy. The cause of fatigue for this one is the depletion of glycogen levels and fat stores. So if we have a look at, say, endurance events that go for, say, more than an hour or so, you'll notice that athletes, the importance to replace those glycogen stores, so obviously to continue to eat, to allow more carbohydrates back into the body so that they can be processed as energy. If we have a look at the byproducts of this, when energy is produced, the aerobic system sends off H2O and CO2, so water and carbon dioxide. So have a think about why we sweat when we do exercise, because our body needs to release that water out of the muscles, and obviously the carbon dioxide is released as a process of breathing out. Having a look at the recovery process for the aerobic energy system, the replenishment of glycogen stores through appropriate dietary intake. So for example, if we're playing sports, or if we've finished playing a sport, having foods that are sort of quick, high in carbohydrates, such as bananas or sandwiches or something like that, which will help replenish the energy stores. Depending on the level of depletion of energy and how long you actually have exerted yourself for, it can take up to 48 hours for an athlete to recover from using the aerobic system. And examples for these sports that might use aerobic system, triathlon, longer distance runs such as 5,000 metres, marathons, or when we look into swimming events like 1,500 metres or open water events. It's also important to note that there are some sports which will actually use all three of these energy systems, and in fact quite a lot of sports. So while there are sports that would be specific to these, so for example shot putters or field events, even some track events in athletics will mainly use ATP-PC system, a lot of other sports will use the lactic acid system, because they will go through that ATP-PC and then tap into the lactic acid system. So for example, 400 metre runner. And then you look at the aerobic system, and having a look at, say, a marathon runner may begin by using that ATP-PC system to initially start the body from the start line. They'll then go through the process of using the lactic acid system, and then once oxygen starts to get through to the muscles from the blood flow, the aerobic system will kick in place. However, that athlete, that marathon runner, then may have to accelerate to take over an opponent or to go up a hill, and may experience the ATP-PC system again, even for something like a finish line sprint. So it's really important to understand that these three systems, while they're very different, some athletes may use them at different times throughout their sporting event or their game, or even within their training, to get the best and most efficient sources of energy.